Hi guys, a very warm welcome, and in this video we are going to talk about some of the AWS application services. And in the application services I would be discussing on implementing the SES, which is a simple email service, demonstrate the working of SNS, the simple notification service, working on the SQS, which is a simple queue service, and implementing the Lambda service, which is a serverless architecture. So let's look into it, what we have in this session. So in the case of an Amazon simple email service or the SES, it works just like an exchange email or an email exchange server, but the email exchange server is hosted on the cloud. So SES is highly scalable and cost-effective platform for sending and receiving the emails. You don't have to set up the email exchange server in the on-prem environment. You get it directly from the AWS, and this is a managed service. So all the email related things, the email related servers would be managed by the AWS in the backend. So what benefit we get when we use the SES? It reduces the complexity of building an in-house email solution and installing and operating a third-party email solution and managing it. You only pay for the messages you send or receive, and it is up to you whether you just want to send the emails or you want to receive the emails also. Some of the use cases of an SES could be in the digital marketing organizations, where you can do a mass marketing, application developers, and online retailers as well. So why we should use SES? SES gives you a high performance. You can send millions of emails in just few hours. It is scalable, so you can increase the email size from 0 to millions in a day without any additional cost. It is a reliable email delivery. It uses in-house content filtering to ensure that it meets the standards of all the internet service providers. So SES is a very secure service, and there are a lot of security checks that happens in the backend when the emails are sent or received on the SES. So, and also it meets all the standard and the compliance issued by the internet service providers as well. Along with that, SES gives you a seamless integration, as it can be easily integrated with other AWS services. Like you can use SES with S3 for storing the logs, SNS for sending out the notifications, CloudWatch for monitoring, and Lambda for the serverless architectures. And along with that, you can easily integrate SES with API gateway and the third-party applications which are outside the AWS. It's a cost-effective solution. The amount you pay depends on the volume and the number of messages you send and receive through the SES. Now, what are the steps to send the email with Amazon SES? So obviously, to send the email, you require a sender who can draft an email and send it to the SES. SES takes that email and forward it to the corresponding internet service providers or the ISPs, and then the ISPs forward it to the respective recipients. Now, for example, let's say the recipient 4C does not want to have this email, raises a complaint. That complaint is sent to the ISP, and the ISP forwards that complaint to the SES and further to the sender. In the logs you can find it. If a recipient is not available, his or her inbox is completely full, then in that case the bounce back notification is sent to the SES, and then the SES sends that notification to the sender. If the email is sent to the recipient, the recipient has read that email, then the acknowledgement can also be sent to the sender. This is a procedure of just sending the emails. To receive an email, there is a separate procedure that you need to follow. You need to first verify your domain. Domain means like from which domain you are going to send an email. Let's say if you're working in an organization and organization has created your email ID, so that domain you are going to specify. Then you have to publish an MX records also. So these records specify which mail server can accept the mail sent to your domain. Then you need to give permissions so that it enable SES to push an SNS topic or write email to S3. You can attach the policies also. Then afterwards there are some IP address filters also. You can activate them, and with the help of an IP address filters you can reject some emails or reject the sources from where the emails are being sent. You can put them in spam also. And then the fifth point is you have to create a receipt rule. So receipt rule defines what has to be done with an email. Should that be sent to a particular domain, or should that be sent to a particular email ID? And it is something based on the settings defined. So this is basically how the receiving of an email rule is created. So what are the operations done by SES after it receives the email? So here you can look into the steps. First of all, when the SES receives an email from the internet service provider, it refers to your active receipt rule, whether the receipt rule is created or not. Then it looks into if there are any matches to reject the email. If there are not any matches, it rejects the email. And if not, if the email is fine, then it is going to forward it to perform the virus scan. The virus scans on the mails are done to ensure it is virus free, there are no trojans or anything, and then it is sent to the specific recipient. So these are the checks which are internally managed by the SES in the backend. What are the common use cases where the SES can be used? Some of the common use cases of an SES are the marketing emails. You can use it for digital marketing, promotions, product advertisements, and running some special offers also. You can use it for transaction emails. So you can send automated emails like shipping, order confirmation status, updates, and other messages that keep your customers informed. Notifications, you can use it to send out notification for system health reports, application error reports, workflow status updates, and any other event that requires reporting. And then you have an option to receive the emails also, where you can receive messages and deliver it to some other AWS services as well. Like you can push it to the S3 bucket. You can do a push notification through SNS also. You can call some custom code using the Lambda functions as well, which is a serverless architecture. Likewise, there can be many other use cases that you can perform, the activities that you can perform with the Amazon SES. Demo, we are going to look into how we can send an email through the AWS SES, and these are some of the steps that you need to follow. Now coming to the next service, next application service, which is an SNS. SNS stands for Simple Notification Service. This service is primarily used to send out the notifications or broadcast the messages. Now you must be wondering, then what is the difference between an SES and an SNS? If the SNS can also send out the notifications, and it can also send out the notifications on the email IDs. See, SES is primarily used only for sending out the emails and receiving the emails also. SNS is just used for sending out the notification. It doesn't receive any kind of an email. And there are many channels on which the SNS can send out the notifications. So here you can see this SNS service can send out the notifications on the email. It can do an SMS on the cell phone also. It can send a notification on the website. It can send a notification on the queue as well. Or it can send a notification to the serverless architecture or an application running on this serverless architecture called Lambda. And there are many other ways we can send out the notifications to different platforms. So SNS is a managed service of AWS that is used to deliver the push messages from the application to the subscriber end or the other application. So guys, what happens is the SNS works in the publisher subscriber form or pub/sub kind of a format. First of all, what you need to do is you have to move to the SNS service, and there you have to create a topic. whatever the topic that you want to create, you can specify the name. And then to that topic, there are subscribers. Those who are going to subscribe to that topic, they are going to get the notifications also. And how the notifications will be sent to the SNS? With the help of a publisher. So what the publisher is going to do? The publisher is going to publish a message, and then it would be sent to the SNS topic, and then the SNS is going to broadcast that message to the subscribers, and that can be any platform. Like it could be a Lambda, it could be SQS, it could be email, SMS as well. So SNS can be used in two ways. One is A to A and the other one is A to P. Now what does A to A means? A to A means the notifications that are sent from application to application. Application is the one like who's going to publish the message. Obviously the message will come from the application to the SNS, and then the SNS has to send out the notification to whom? If that is an application, then it becomes an A to A service. For example, SNS sends a notification to HTTP or the HTTPS, SQS or Lambda. Then it becomes A to A. If SNS sends a notification to the email ID of a person, to the cell phone of a person, then it becomes A to P. So likewise, it is up to you how you want to use SNS. You can integrate it with your current solutions also. So how does the SNS works? Obviously, as we know by now, that first of all we need to create a topic which acts as an access point in the SNS. Then we have to set the policies to limit the access to either publish the message or subscribe to notification. We need to set up what type of subscription we want. Or do we want to send it over the email, SMS or any other channel? Then the subscribers are going to subscribe to the SNS topic, and then once the subscriptions are done, publisher is going to publish a message to a topic. The SNS topic is going to get that message and send it or deliver it to all the subscribers. Simple, quite a straightforward thing. How do you want to integrate it is up to you. You can integrate SNS with various different AWS services. Even you can integrate SNS with some third-party API tools which are outside AWS as well. And from there itself you can send a message as a publisher as well. So I would recommend that you read some case studies, and you're going to get a lot of case studies where SNS is used for sending out the notifications to various different subscribers and automating the notification sending procedures. Now what are the benefits of SNS? Easily integrates with the applications, instantaneous push-based delivery, send messages individual or broadcast, point and click interface. There are multiple transfer protocols that you can use, pay-as-you-go model or on-demand model. You can even use the SNS for mobile push or sending a push notifications on the cell phones. But for that, the SNS helps to send out notification to the apps on your mobile through push mechanism without opening your application. But for that, you need to take the help of your service provider also, because there are some tokens that are generated. And also you need to look into whether it comes under the compliance or not based on the regulatory authorities as well. Demo, send a notification through SNS. So we are going to see in the lab video that how we can send a notification to the subscribers with the help of a publisher via the SNS service. Now another type of a service is Amazon SQS, which is a simple queue service, and it is primarily used for the message queue or queuing the messages in the SQS. So with the help of queuing the messages in the SQS, any backend application can query the messages, retrieve it from the queue and process it accordingly. So SQS is a messaging queue service that handles messages or workflow between other components in a system. So here you can see in this diagram, this is an SQS. Messages can come from various different sources, and these messages are stored or queued in the SQS. And then in the backend, the application can poll the queue and start receiving the messages and do the activity or take an action on those messages. So where exactly you can use SQS in the real-time scenario? There are many ways, there are many places where you can use the SQS. You can use it for order management, order processing, like in the e-commerce platforms. You can use it for ticketing system, booking online ticketing, booking cinema tickets, booking airline tickets, and also in case if you're requesting for a new credit card or a debit card, all these messages can arrive to a queue created by the organization. And their backend team is going to retrieve those messages from the queue and process accordingly. So likewise, I would suggest you read some case studies for the SQS also. Both the SQS and the SNS, they are the asynchronous services, which means that either you can use them as an individual service just for their own functionality, like for queuing the messages or for notifications, or you can integrate with your current solution also so that it can be more efficient with the introduction of these services. Now, polling the queue, there are two forms. One is long polling and the other one is the short polling. So when you do a short polling, the backend application server sends a request to the SQS, and let's say if a queue is empty, it returns an empty message to the backend application. Whereas in the long polling, what happens is when the backend application sends a message request to a queue, and let's say if a queue is empty, there are no new messages in the queue, it still waits till the message is received and then send it back to the server. So the keep alive time in the long polling is more as compared to short polling. Then there is another concept that is called as an SQLS visibility timeout. So what exactly the visibility timeout is? It is a period of time that prevent other customers from processing the message. That is called as the visibility timeout. For example, if you look into this diagram, let's say these are the backend agents who are going to process the messages, and they are going to get the messages from the application running on the server. This application is going to poll the messages from the queue, and once they receive the messages from the queue, these messages are picked by the backend agents. Now let's say there are three agents who are polling the queue simultaneously, and if this agent and this agent opens up the same message, then the duplication of an order processing happens. The same order is processed multiple times. So in order to prevent that activity, what happens is there is an SQS visibility timeout, and you can specify the time period for that as well. For example, let's say if this individual opens up a message and working on it, at the same time, if another individual polls the queue for the messages, that individual will not be able to view or open the message that the previous or their colleague is working on. And this is what makes the SQS special, so that it prevents the duplication of the order processing. So visibility timeout is very much used in the e-commerce platforms like in Amazon.com and all, where once the orders are processed by the agent, at the same time the other agent cannot open up that order or a message. Coming to the next part of an SQS, the dead letter queues. Now what you can do on the SQS is you can configure a dead letter queue also. Now what is the functionality of a dead letter queue is? For example, let's say because of any reason, or let's say if a backend server or an application is not working correctly, or let's say the stock is out of, if the company is out of stock, but still their products are being displayed on their website. Now when a customer adds a product to a cart and go for a purchase, at that time the error message is thrown that we are sold out or the product is not available. So in that condition, what happens? These orders or the messages can be sent to a dead letter queue, and this dead letter queue can be used by the operational managers or the team leaders or those who are managing the department to analyze where exactly the fault was, what was the error, and to troubleshoot and rectify that. This improves the performance of an application. So dead letter queues are something which stores up the errors related to the SQS or errors in performing a particular job or an order processing. And later on, that errors can be analyzed by the reporting by the team managers or those persons who are leading the department to rectify the issues. Dead letter queue is always an optional thing. It is not a mandatory thing, but just it enhances the architecture. Now, what are the SQS features? SQS is reliable. It runs in Amazon's high availability data center. It's a completely managed service by the AWS. It does the message batching for the higher throughput and reduced cost. It is scalable. Scalability is also managed by the AWS. It holds a message until you explicitly delete them. Fan out option is also there. When it is SQS can be combined with the SNS, and it can send multiple copy of messages to multiple queues parallelly also. And flexible, as SQS offers you to create two different type of queues. One is the standard and the other one as a FIFO queue, which is a first in first out. So what types of SQS queues that you can create? There are two types of queues that you can select. One is the standard queue and the other one is the FIFO queue or a first in first out queue. The standard queue, which means the order of the message in which they have sent might be different from order they have received. So what happens with the standard queues? Let's say if you plan to create a standard queue, you can receive a message randomly from various different sources, and they can be picked for processing also randomly. There is no order that is followed. Let's say a credit card request. So it can be picked up based on the availability of an agent in the backend. But the only drawback with the FIFO queue is that it has a limitation. So you can always refer the AWS documentation for the exact capacity or the limitation that the FIFO queue offers. So right now the FIFO delivers up the limit somewhere close to 3000 message per second with batching. In the standard queue, it guarantees that a message delivered at least once. Whereas in the case of a FIFO queue, message gets delivered only once, where the duplicates are not allowed here. Now, standard queues can be used with an example to help to validate large number of credit card requests, debit card requests, new checkbook requests. Likewise, there can be many other examples. Let's say if somebody make a request for a course learning, AWS course learning. Likewise, the FIFO queue is specifically used where there are limited seats. Let's say if a student enroll for a course where there are limited seats only, or if anyone tries to book a match ticket but there are limited seats in that match ticket. So first come first basis it will be served. So that is what the SQS is all about. And the next application service that we are going to discuss is the serverless computing. So what is serverless computing? As the name suggests, serverless computing means you get the computing capacity or computing task done by a serverless mechanism, that you do not have to create any kind of a server. So for example, in the serverless computing, you do not have to provision a server or manage a server. It scales with the usage. So no need for setting up an auto scaling. You do not have to pay for idle. Let's say if you upload a code on the serverless computing mechanism and it is not triggered, there will be no charges. So the charges comes only when the code is triggered. So that's one of the most, or you can say one of the best benefit that you can get from the serverless computing, that the charges are only paid when the code is executed, and the charges are on a millisecond basis till the code gets executed. Then you have availability and fault tolerant built in, which is managed by the AWS in the backend. And here you do not have to manage, or you do not have to create any kind of a component. So components are very less. So it becomes easier for the developers to think and focus more on developing their code, building up an application, and then directly put it on the serverless mechanism to execute. Now, when we talk about the serverless computing, we generally focus on the Lambda. So AWS Lambda is a service that offers the serverless computing. Lambda is serverless compute platform where you can run a code for any type of backend service in response to events. What does that mean? For example, this is the symbol representation of a Lambda is all about. And you can just create a function from the Lambda, select your runtime environment. Let's say if you're going to build up a code in PHP, Python, Java, you just create a code and put it on the Lambda function. Automatically it will be executed whenever the Lambda function gets triggered. So the Lambda helps you to create two types of functionalities. One is a compute driven functionality and the other one is the event driven functionality. Now what does it mean? In the case of a compute driven functionality, you can run attributes without managing a server. For example, let's say if you host your website on the Lambda, you can get it triggered from the HTTP request or the HTTPS request. The website will open. That's a compute driven functionality. Or you're just using the Lambda for hosting your backend applications. Event driven functionality means that some event would occur that is going to trigger the code on the Lambda function and you get an output out of it. So in the case of an event driven functionality, the code only runs when it is required. And in this event driven, you can add the events or the triggers. Multiple different type of AWS services you can add it as a trigger. Like you can add a CloudWatch also as a trigger. You can add an SNS also. You can add an S3 also. And guys, with the Lambda, you can have lot of solutions that you can create which are not possible directly to achieve. So with the help of a Lambda, you can automate your IT infrastructure. You can get your projects completed. You can basically create a pipeline also, and thousands of use cases you can get it from Lambda. Just that you need to know how to build a code and use it on the Lambda function. So how AWS Lambda works? What you need to do is, first of all, obviously you need to build up your code and then you have to upload your code to the AWS Lambda. Afterwards, you set up your code to trigger from other AWS services like HTTP endpoints or in-app activity. After that, Lambda runs your code only when it gets triggered, and the billing is on a millisecond basis or sub-second basis. What are the benefits of using the AWS Lambda? One of the benefits of using the AWS Lambda is no server to manage. It automatically runs the code without managing the server, where we can just write the code and upload it to Lambda and then we can trigger it. Continuous scaling. It automatically scales and runs the codes in parallel for each individual trigger. Sub-second billing. It is charged for every 100 milliseconds the code executes and the number of time the code is triggered. And likewise, there can be many other benefits of an AWS Lambda. Like you can automate your IT infrastructure. You can have a pipeline created. You can create a code in different development environments and post them on the Lambda function likewise. What are the event source that can be integrated with Lambda? So these are some of the events that I have mentioned in the slides, but there are many others. So some of the event sources that can be integrated with AWS Lambda could be S3, RDS in the database section, DynamoDB, AWS Kinesis. You can use simple email service and the simple notification service also. CloudFront can be used. API Gateway is one of the popular event trigger for Lambda function. CloudWatch is another popular trigger for the Lambda function. Likewise, you can integrate the IoT or the Internet of Things devices. And along with that, there are many other services that are not mentioned in the slides, which you can find it in the lab demo, and you're going to get to know that what all event sources that can be integrated with the Lambda. Now, what are the common use cases of AWS Lambda? So there are some of the common use cases that you can use with the AWS Lambda. You can create a web application, you can host a static website, even a dynamic website also. You can create a complex web applications, packages, the backend applications also you can create, host them on the Lambda, integrated with your front-end applications. You can use it for data processing, like a real-time data processing. You can create a batch operation also. You can use it for creating chatbots. Even you can integrate Amazon Alexa with the Lambda function as well, where you can enable the voice based tasks. You can also do an IT automation where you can automate entire IT infrastructure, like automate updates on the upgrades and patch upgrades, license upgrades, and all those things. And likewise, as I mentioned, in the AWS Lambda, with the AWS Lambda, you can have thousands of functionalities. You can always refer some of the case studies that are available in the AWS site, and that would give you a very good understanding on the working of the Lambda function. And it is quite an important service to work on and understand as well. So in a demo, I'll be taking up a functionality where I'll be taking up a requirement where we need to